I am now ready for encapsulation. I've got a source IP, a destination IP, a source port, and a destination port. I've identified my application that's being used. I've got a source MAC and a destination MAC. I'm ready for encapsulation. This is what really happens in a TCP/IP conversation. Remember, encapsulation means that the layer 2 protocol, which in this case is going to be Ethernet, is going to frame it up and get it ready to be sent out across the wire. This is what it looks like. Here's our original system asking for Cisco.com. It passed application data, which was based on the HTTP protocol web data. It passed it down to layer 4, where the TCP and UDP port was added to it. This was that header, that layer 4 header. Now, remember that all TCP/IP applications function at layers 5 through 7. So there is not a separate layer 7, layer 6, or layer 5 header. It's all just pure application data passed under layer 4. Here is that layer 4 header. This information is then passed down to layer 3. Notice my port. So I've got application data, a layer 4 header, added to which is a layer 3 header, the IP source and destination. At this point, the MAC address is identified, and those MAC addresses that we found are going to be added to this. This becomes the layer 2 information, which is now ready to be encapsulated. So here is my MAC. Now at this point, framing is going to occur. Network access is layer 2. Since I'm framing this particular packet for Ethernet, this has got to be framed properly so that the other end can understand it. The first thing that happens is that a startup frame is added to it. This is something known as a preamble. What is a preamble? It's a string of zeros that indicates that the beginning of a frame has happened or that a frame is to follow. We then will have a calculation beginning with the layer 2 MAC addresses all the way through the application data, and it will come up with that frame check sequence, or CRC, which is a computation of all the data from here to here. That, once calculated on the other end, can verify that the frame has arrived in the proper order and without corruption. Once this has occurred, it's converted into bits and can be sent out across the wire.